Hi, this is our team project on tanker scheduling DSS. So the goal of our project is to have our program to schedule all the temp shipments to 5 different cities in the Mediterranean Sea. So all the 10 shipments will start from Barcelona, you see up here on the green arrow, and it will go through 2 of 5 cities which are in circles in the map, and at the end they will all end up by going to Alexandria. So now we'll start our Excel. So here's our routing sheet, and we'll run through the simulation first. So what the graph is showing is all the shipment will start from Barcelona on each day, and every day the graph will show a different ship movement to different cities. And when a ship gets to a destination, it will have a unloading day of 1. So on that day, the ship will be disappeared on the screen for one day, and when it's ready to go, it will reappear and then move on to the next city and end up in Alexandria. And here's our view data sheet. So here are our ship numbers, as you can see here, and they all start in different days from day 1 to day 10, and each shipment have a different port destination for the first port and the second port, and they all have dedicated different due date to be shipped. And here's our array of the optimal route from one port to the other port. So I go back to the result, and if you see down here, when it goes through each day, it will show you the current day and the total cost that is spent. So we have assigned each cost to each shipment and travel for each day. Now I will pass it to Caleb to go to the code.
Yeah, so for our code, we needed to make a bunch of arrays to store different values for our project, and so we made like several sized arrays for ports and ship starts, ship ends, ship movements, distances, minimum distances, max distances, and various different arrays. And so basically this first sub was just initializing all of these for each of the 10 ships, and we went through and did several different methods of determining the optimal way to initialize these arrays. The one main code we did was to select the minimum city and the maximum city from the list of ports that the ship needed to go to. And so to do this, we looked at the distance matrix that we presented before, and we found the minimum distance for the 2 ports that were selected, and did a case statement, and then labeled the first port as that port, and then we found the max and made that port the second port that it would need to go to. And then we also had some variables for if there was land on the up, down, left, or right of the ship, and those were Boolean. So then what we did, we called the next day sub, which would basically just run each day for the 30 days. And it was just a for loop. It would call the deploy sub and the finish sub, and then it would also calculate the cost by summing up all of the movements and then multiplying them times 100, which was just a arbitrary number we came up with for a movement cost each day, and then also add the penalty incurred times the penalty amount, which we will present in a little bit. And then it would present the day and the cost on the sheet. and then it would also wait between each day a second to allow the ship's time to movement, and you could see the movement. So the sub deploy, and here's the sub finish, is pretty simple. Basically just checks to see if the day is greater than the ship end date that was previously established. If it is, then a penalty is incurred, and so that penalty is added to the cost because it was not met, or has not met the due date. The main sub would be the deploy sub, and so this is where most of the movement and calculations are run. And so it's basically one large for loop for all 10 ships. Basically first it checks if that ship has started. If it has, then it increases the movement for that ship and also moves or makes the ship visible on the water. And then if the ship start is less than the current day, which means the ship has already started, it also will move the ship. And so if it's not at its first port's column, if the column for the ship position is not equal to the first port, then it will check and see if the ship is visible, and if it is, then it will check and see if the column equals the first port column and the row equals the first port row, which would mean the ship was at its destination. If it is not, or if it is, then the ship becomes false. Visible is false because it is hidden. It goes into the port, and then it will, depending on what port was the one it entered, it will become occupied, which means no other ship can go in that port that turn. And then if it is not at its destination, it will check and see if there's land to the right, and if not, then it will move right by calling the right function, and the ship position will move one column right, and the ship movement will be increased by one. Else it will call down. So this is kind of a heuristically made to avoid land, and basically it would check right and then down, so it'll either move across or vertical each time based on if there's land next to it. And then finally, the if it was already hidden because it was in a port, then it becomes visible, and its second port becomes its first port because it has already completed the first port journey. And then the second port would become the end port, which was Alexandria. And then the ship movement would be increased, and it would make whatever city it was just in unoccupied. And then else, if it was greater than the column, so if it had already horizontally passed its destination, it will go through the same set of constraints and check to see which is true. And the only real difference was it would go left instead of right because it needs to go back to go to its desired port. And then the next part would be if the row is less if the row is not equal, and if it's less than its desired port, then it will go through the same calculations, and it will move down if it can. Otherwise it would move right, because if there was land or if it needed to avoid certain areas. And then the last one would be if it was already lower than its desired port, then it would go up instead of down. And then finally, if that's not the case, then the ship becomes visible because it was in a port. So here is the land sub, and so it checks basically for up, down, left, and right. If there is, if the cell's color is green, which means that there is land, and then it will make land up, land down, land right, and land left variables either true or false based on what is the current or the correct value. And then here are the movement subs, which I'll have Jim go through and explain.
So the movement subs are pretty simple. So I have total 4 movement subs: down, up, right, left. So what each sub will do is it will create a range called post, and for each ship's I through 10, it will uh, it will command each ship to go either to top, down, or right or left. And at the end of our simulation, we'll have all the ships to reset to the original cell, which is a Barcelona cell, and that's pretty much it. And now we will have Joy to talk about the user form.
All right, so what we showed you previously was for our demo data. What I'll show you next is something we didn't get to finish, but would be if the user wanted to input their own data. So going back to the start application, it says, would you like to use demo data? We'll click no, and up will pop our user form that we made. For each of the 10 shipments, we're going to enter the data as far as which shipment number to schedule, start, end date, and the 2 ports that the ship will have to go to before it hits Alexandria. So we are going to try shipment number 1, do start date of 2, end date of 15, and let's say we pick Naples and Tripoli and hit OK. The form will recognize that we successfully inputted an input, and we click OK, and it'll refresh it. So the user can do this for all 10 ships and can go back and change whatever they want. And once they get to ship 10, as noted above, they will enter the start day, enter the end day, enter the 2 cities they'd like to go, the ship to go, and once they click OK, it will say thank you, all inputs recorded, and then it'll close the user form. So with more time, we would be able to develop this and the map to work for the user inputs of traveling to the different cities. But thank you for watching. This was our group project for ENGI 430.